Okay, chapter 5, talking about net present value and other investment rules. So I'm going to go through each of them, and we'll just talk about the strengths and weaknesses of each methodology, and basically explain why net present value or NPV is a preferred methodology. So, key concepts and skills. Compute payback period, discounted payback period. Understand again. All of these we're going to talk about benefits and shortcomings or deficiencies. Compute internal rate of return or IRR, profitability index. Understand the strengths and weaknesses of both of those. Be able to compute net present value. Most people refer to that as NPV, and then understand why it is the best decision criteria. Chapter outline. So first, why use net present value or NPV? Then we'll go over the payback period method, discounted payback period method, internal rate of return, problems with the IRR approach, and then we'll talk about profitability index, and then we'll talk a little bit about capital budgeting to complete the chapter. So net present value, why do we use it? Mentioned this in previous lectures, but this is accepting positive NPV projects benefits of stockholders. So we determine a required rate of return based on the company's cost of capital and the risk of the project. So if the return on that project is greater than that cost of capital, then it increases the value of the firm. So that's why a negative NPV project would reduce the value of the firm. So NPV uses cash flows, uses all the cash flows. It discount the cash flows properly at the required rate of return. One of the things we'll learn about internal rate of return assumes that all cash flows are reinvested at that rate. It's an unrealistic assumption, especially in today's world where we have very low interest rates. The NPV rule or net present value rule. Net present value is equal to the present value of all future cash flows plus the initial investment. I don't really like it written that way. The initial investment is an outflow, so it's a negative. So what they're saying here is plus a negative. So just remember that you're always going to be subtracting out the initial investment. So to estimate NPV, we estimate all the future cash flows. How much they're going to be and when they're going to occur. Determine our discount rate. Determine our initial costs. And then minimum acceptance criteria. You accept the project if the net present value is greater than 0. So what we're doing here is we're taking, let's see if I can. There we go. Taking all the future cash flows and present valuing them back to today, so we can compare these cash flows to today's dollars. So that's how. So if it's positive, you accept it. If it's negative, you do not accept it. So. Ranking criteria. So if we have projects that are mutually exclusive, say we have to pick one or pick conceivably you could have to pick 2 out of 5 potential projects. You would rank those and choose the highest net present value. So, using spreadsheets. So the spreadsheet's a great way to calculate net present value. Excel has a very nice function that will do the calculation for you. You just enter the cash flows, the NPV function. The first component you enter is the required rate of return. As a decimal, that's important. On your calculator, you will enter the required rate of return as a whole number. The second component is the range of cash flows, and this is important here, beginning with year 1. So I'm going to bring up a spreadsheet and I'll show you the right way and the wrong way to go about this. So yeah, we're not, you should be able to, if you view if you view the slides, you should be able to click on this icon and bring up this same spreadsheet that I'm going to show you. So then you add, or in my mind, you subtract the initial investment. That's the way the book presents it. So let's go find the spreadsheet. All right. All right, so here's a spreadsheet. You can't see the whole thing, but we've got the years up here. We've got 3 years of cash flows. The 165,000 is the initial cash flow. So the incorrect way to do this is a NPV. See, we have the NPV function, and I'll type in. If you click on this FX, it'll show you the formula. And so we got B4, which is the required rate of return, and B2 to E2. This is the incorrect way to do it. So we'll move down and I'll show you the correct way to do it. And so what we do is, since we've got the cash flows entered as a negative, so it's NPV. So we got NPV, and then B4 here is the required rate of return. C2 to E2 are the cash flows. So this is C2, D2, and E2, and then we add back this negative to get our net present value, which is $12,627.41. So if you're doing this, what you're saying is that this $165,000 is occurring 1 year or 1 period in the future. That's why it's a mistake. So, all right, let's move on. Okay. All right, so payback period. How long does it take the project to pay back its initial investment? So payback period is the number of years to recover your initial costs. So the acceptance criteria is set by management. Payback period is something that was used historically because it doesn't require a financial calculator to calculate it. It's simple, easy to understand, so forth. So management is say, we need our money back in 3 years. So that's as simple as that. So the ranking criteria, again, set by management. The disadvantages, biggest of all, ignores the time value of money. You're comparing dollars that are received on different dates, which is obviously a mistake. Ignores cash flows after the payback period. So there could be 10 years of cash flows that occur after the payback period. Those should all be considered. It's biased against long-term projects. You could have a long-term project that is extremely profitable, but because of some arbitrary criteria, it could be ignored as a result. Um, requires an arbitrary acceptance criteria. The the project accepted based on payback criteria may not even have a positive NPV. Advantages, it's easy to understand. So it's biased towards liquidity. And so next lecture, we'll start talking about discounted payback period that solves some of the problems associated with payback period.